Assalamu alaikum wa rahmatullahi wa barakatuh. Well, we continue in chapter 8, lecture 2, structuring system data requirement. So we will finish the ERD in this chapter. Okay, what's a candidate key? A candidate key is a column or a set of columns. Other words, represent an attribute or a set of or a combination of attributes in a table that can uniquely identify any database record without referring to any other data. Each table may have one or more candidate key, but one candidate key is a unique, and it is called the primary key. Of course, the candidate key, it has to be like one attribute in order to make it really a primary key. An attribute or a combination of attributes that uniquely identifies each instance of any entity type. Example here, we have employee ID, employee name, and employee address. Because we have two candidate key, we select a employee ID as identifier. So we could really look at this table, which has really two keys. One of them employee ID, or we could really have an employee name and employee address, because employee name and address which will make it really unique. Instead, we really give them an ID, and we replace the employee ID name and the employee address with the employee ID. And since it is the employee ID, it's one attribute, so we consider it as a primary key or identifier. Identifier, a candidate key that has been selected as unique identifying characteristic for any type. Okay, a candidate key that has been selected as the unique identifying characteristic of any entity type. Again, another definition. Selection rules for an identifier. First of all, choose a candidate key that will not change its value. Choose a candidate key that will never be null. First of all, it's not changing its value, then it will never be a null. It has to have a value all the time. Avoid using intelligent keys. Intelligent key, when intelligent key, which it is when you have the attribute, it has many characters or many integers, and each integer represents something related to the business rules or to the business you have. Like example, if you look at the chassis number of a car, you will find that it's I believe 14 or 17 integer and letter. Each one or two characters or numbers, they mean something. I remember, in Detroit Diesel, when we used to have the model number. The model number, for an engine, it has like the position 3 and 4, it is the type of the engine. Number 8, it is another thing, how many cylinder. Type of the engine, it's the right away. So the engineer, when you call the engineer and you give him the chassis number or the model number, whatever, he or she knows that this type of engine or this type of car, it is some specification of that engine or that car. It's like, the student number. Not now, before we changed a couple of years ago, we used to have like the year and then the major of your college, and then a number there. So you could see like used to be like 71 for computer science, 72 for something, 73 for CIS or whatever, So from the intelligent key, you could find a lot of information about the attribute or the instance of attribute, the one you talk about. Consider substituting single value surrogate keys. I mean, for a large composite key. We said, when we talk about the candidate key, we said it is an attribute or a composite of attribute, combination of attributes. If that's the case, when you have like a two attribute, which it is identifying that record or identifying that thing, we could consider them as really a key. It is good to substitute these with a single value. It's like the one we saw, like the name and the address of the employee, we substitute it with the employee ID. Well, multi-valued attribute. A multi-valued attribute of an entity is an attribute that can have more than one value associated with the key of the entity. For example, a large company could have many divisions, some of them possibly in different cities. That's one example. There are many divisions. So it has the division and the address and the name of it, blah, blah, blah. Multi-valued, an attribute that may take one or more than one value for each entity. An attribute that may take one or more than one value for each entity instance. Multi-skills for one employee. Like employee, the skill, he has multi-skill, you could write. Represent an ER diagram in two ways. A double-lined ellipse, you have it a double line, or a weak entity, employee and dependent name, age, and relation. Like a weak entity, the one we talked about it in the last lecture. It is a double-lined around that entity. Repeating group, a set of two or more multi-valued attributes that are logically related. As we did explain about what the multi-valued, if you look at the employee, there's employee ID, employee name, payroll address. Employee ID is the primary key here, and the skill. Probably the employee has many skills, so it has many values here. But repeating a group of dependent, like the dependent. When we talked about the employee, we have the employee ID, and then he has 2 or 3 children. So you have the name and the age and the relation. Name, age, and relation. Name, age, and relation. That's what. The third one, it is represented as a weak entity for dependent data. You could really do it this way, like you have an employee and then the weak entity, which it is the double line around that entity. With the dependent, it has a dependent name and age and relation. Other attribute types required attribute, which attribute that must have a value for every entity instance. Optional attribute, an attribute that may not have a value for every entity instance. Composite attribute, a composite key or attribute is one that consists of more than one attribute. If the ER diagram contains an attribute name, it has a meaning, for like the first name, second name, and last name, or middle name and last name. Then for derived attributes are that attributes that do not exist in the physical database, but their values are derived from other attribute presented in the database. An attribute whose value can be computed from related attribute values. Derived attribute, it is not really present in the physical database, but we could calculate it from other attributes. It's like the age. We could find out from the birth date. We look at the birth date and current date, and then we subtract the birth date from the current date. We come up with the age. Well, relationship are association between or among entities, between one or more entities. When there is another type of, which is a weak relationship, are connection between a weak entity and its owner. There is a weak entity and the owner of it is a strong entity. Relationship are an association between the instance of one or more entity type that is of interest to the organization. Association indicate that an event has occurred or that there is a natural link between entity types. Example, relationship are always labeled with verb phrase like student and course. Student is an entity and course is another entity. Relationship Student completes. So the verb here is complete course. Student complete course. Entity, relationship, and entity. Student completes course. Degree, the number of entity types that participate in a relation. So the relationship student complete course is of degree 2, since it has two entities, the student and the course. If we look at this example, the employee and the course, or let's see that as student and course, but employee, this is for a company. The employee, the entity employee, it has the employee ID as the primary key, employee name, birth date, etc. And the same for the course title, topics, etc. The relation here, it is many to many. See the fork, which it is employee completes course. If we look at the employee, like Shen, Milton, Richie, Selco, and Gosling. And the courses are C++, Java, COBOL, Visual Basic, Perl, and SQL. If you look at Shen, is complete the course C++, Java, and Visual. If you look at Milton, finish the C++, COBOL, and Perl. So the relation here is many student to many employees. So it is many to many here. Well, if we look at the degree, what degree means here? Degree is the number of entity sets that participate in a relationship. We have three types: unary relationship, binary relationship, and ternary relationship. Unary relationship, a relationship between the instance of one entity type, also called a recursive relationship. There is one entity, and we'll see an example soon about the unary. Binary involve two entities, a relation between instance of two entities, most common type of relationship encountered in data modeling. Usually that's always when we talk about a relationship, we talk about two relationships. But sometimes a recursive one, sometimes, or probably it's rarely, not rarely, but I mean it's like employee, married employee. Both of them are employee, both of them work in the same company, whatever, but we talk about the same entity. Both of them, it has the name and the address and whatever in that entity. So the relation, it is a unary relationship. Ternary relationship, simultaneous relationship among instance of a three entity type, which is the associative entity, and the one we could see the example of it soon. Well, for the unary, as we said, it involves one entity only, like, in a person, it is the relation one-to-one. Person is married to a person. For the employee, one-to-many, again, it's like employee manages employees. And the team, one-to-one team, like stand after. The relation, it is stand after the team. If you look at the binary, it's involved two entities, like employee and parking space. This is one-to-one. Employee is assigned to a parking space. Or one-to-many, like a product line and a product. Product line contains many products. Or we have many-to-many, like a student and course. Many students register in many courses, which this is a binary involved. But if you look at the ternary would involve three entities, like the vendor and the part and the warehouse. And the relation, all of them, it is many to many to many. If we're looking at shipping mode, a unit cost of a part number or item number in a company. The company, it deals with many vendors. It has many parts. It has many warehouses. We try to find out that shipment, how much the unit cost and that shipment for that item. So we need to get information from all these three. Which vendor, what parts, and to which warehouse are they sending that shipment in order to find the information about that item or about that part, like unit cost or the quantity. Because the part, it could come in many different shipment. But to which warehouse? Warehouse 1 or warehouse 2 or... What's the cardinality? Cardinality is the number of relationship instances an entity can participate in. It includes the relationship types like one-to-one, one-to-many, and many-to-many. The number of instances of an entity B that can or must be associated with each instance of entity A. There are a minimum cardinality, which is the minimum number of instances of entity B that may be associated with each instance of entity B. A. Maximum, the maximum number of instances of entity B that may be associated with each instance of entity A. And all these, it depends on the business rules. So the minimum, it could be a 0. Maximum, again, it could be 2, 3, 4, etc. Well, cardinality is also understood in terms of optionality. Two entities may have a mandatory relationship. They must be related at least once. Or an optional relationship, they do not have to be related at all. If an entity exists, it must be related to a second entity. Mandatory versus optional cardinality specify whether an instance must exist or can be absent in the relationship. Well, let's look at here and differentiate between mandatory and optional in the cardinality. If we look at the first one, patient and patient history. Patient has recorded patient history. This means if we have a patient, then we have to have a patient history, no matter what. So it is mandatory. Mark, it has a visit 1, Sarah, it has visit 1 and visit 2. So the history of Sarah, it has, visit 1 and visit 2. So if we have a patient, then we have to have patient history. This is mandatory cardinality. One optional, one mandatory. Employee and the project. Not every employee has to have a project, because sometimes we don't have a project for all employees we have. And that's why we see the project there with the fork and we see the optional one. So employee is assigned to project, probably to many projects, or to no project at all. So one optional, one mandatory cardinality. The third one is optional cardinality, both of them. It's like, a person is married to a person. We have, like here, Kathy and Mac. We have Alice and Shirley. Those are married. We don't have Fred and Don, they are not married. And probably we have none of them are really married to each other in that entity person. So it is optional cardinality. Well, how we gonna name the relationship here? It's a relationship name is a verb phrase. Avoid vague name. Make it clear. Like a student studies. Student takes class. A relationship definition. Explain what action is to be taken and possibly why it is important, and give example to clarify that action. And the relationship definition should explain any optional participation, if there is any. Explain the reason for any explicit maximum cardinality other than many. I mean, if there is, the cardinality is up to 4 or up to 3, like many to many with maximum 4, I think you should explain it. Explain any restriction on participation in the relationship. Explain the extent of history that is kept in the relationship. Explain whether an entity instance involved in a relationship instance can transfer participation to another relationship instance. Well, associative entity. Associative entity is a term used in relational and entity relationship theory. A relational database requires the implementation of a base relation or a base table to resolve many-to-many relationships. This means we have many-to-many relationships, but we need to create a third relation to fix that problem. A base relation representing this kind of entity is called informally an associative table. It is an entity type that associates the instances of one or more entity type and contains attributes that are particular or peculiar to that relationship between those entity instances. Sometimes we call it gerund. The data modular chooses the model to the relationship as an entity. So we'll come up with the example in the next slide. Well, if we look at this example, look at employee and course. The relation between B and A, the B is the employee and the course is A, entities are many-to-many. Optional, of course. The employee, it could have many courses, and the course, it could be taken by many employees. So how are we going to find the date completed for a specific employee or a specific course? The date completed, it doesn't belong to that course, because that course, it has many different date completed. It doesn't belong to that employee, because employee, it has many different date completed to that course. Because if employee Ahmed is finished the course in summer, then the date completed summer. But in the meantime, somebody else or that course has been taken again in the fall and the spring, and Ahmed is taking another course in the spring, and he has many different date completed, whatever. So the word date completed, or the attribute date completed here, it is not peculiar, or it's not particular, or it's not belong to employee or course. So what really the solution for it here, we have employee and course, then we give a certificate there. So we put a third entity there with a certificate number and then date completed. And the relation now, it is, employee and course completed, and there is a certificate. The relation here, if that employee finished that one, it becomes mandatory. It is one-to-many. So that employee take many different courses with many different date completed, and the relation between these date completed is the one between the course and the certificate. So it's easy, you could find it. The one on the bottom, it is the way Microsoft Visio put these, with different symbols or different notation. Well, summary of conceptual data modeling with ER diagram. The purpose of ER diagramming is to capture the richest possible understanding of the meaning of the data necessary for an information system or an organization. Well, how are we going to represent a supertype and subtype in the ERD? Let's go with the supertype first. Supertype is an entity type that has got a relationship, parent to child relationship, with one or more subtypes, and it contains attributes that are common to its subtypes. Subtypes are subgroups of the supertype entity and have a unique attributes, but they will be different from each other or from each subtype. Supertypes and subtypes are parent and child entities respectively, and the primary keys of supertype and subtypes are always identical. A subtype is a subgrouping of the entities in an entity type. It's meaningful to the organization, shares common attribute or relationship distinct from other subgroup. Like we have outpatient, inpatient. We have student, employee, and alumnus. We have undergraduate, we have a graduate. It's we have, like for a student in university, in a college, we have a graduate student and a graduate student. For a patient, we have inpatient and outpatient in the hospital. We have employee, we have, could we have, in the university, could we have a student or employee or alumnus, خريج. For a supertype, a generic entity that type has a relationship with one or more subtypes, like patient, person, or student. Okay, what's a total specialization and partial specialization? Total specialization rule demands that every entity in the superclass belong to some subclass. Just as in a regular ERD, total specialization is symbolized with a double line connection between entities. Double line connection, as we're gonna see in the next example. The partial specialization rule allows an entity to not belong to any of the subclasses. In other words, total specialization specifies that each entity instance of the supertype must be a member of some subtypes in the relation. Example, student can be only either a graduate or undergraduate, cannot be both. Or person must be a student, employee, or alumnus. A person in university could be a student or employee or alumnus خريج. But in the partial specialization, specify that an entity instance of the supertype does not have to belong to any subtype and may or may not be an instance of one of the subtype. An employee can be faculty or staff, or just an employee. This means it cannot be, a staff and faculty. An employee can be a faculty or staff. Employee in a, like in, let's see, in just can be either a staff or a faculty. Either موظف عادي دائرة أو إنه بدرس بالفاكولتي whatever. Or just an employee. Cannot have really both of them. Well, let's look at disjoint and overlap rule. A disjoint rule states an entity instance of a supertype can only be a member of one subtype. But the overlap states an entity instance of a supertype can be a member of multiple subtypes. The disjoint specifies that if an entity instance of the subtype, the supertype, is a member in one subtype, it cannot simultaneously be a member of any other subtype. This means it has to be in one subtype, not more. Student is a graduate or undergraduate. But overlap rules specify that an entity instance can simultaneously be a member of two or more subtypes. A person can be employee or alumnus or student, or a combination of these types. This means a person in university, it could be an employee or alumnus, like, a student who finished his degree a couple of years ago. He is a خريج, he is alumnus. In the meantime, he is working now in the university. Well, if we look at this figure 819, example of supertype and subtype hierarchy, we see the person and underneath it employee, alumnus, and student. The double line there, we should see that it's a must have, The O, it's an overlap. The person could be an employee and alumnus, or employee, alumnus, and a student. It could be, he is an alumnus, خريج, bachelor. He's studying, he's a student and graduate, and in the meantime is an employee. So the the O is here represent the overlap. But if you look at the C relation between a student, undergraduate, and graduate, it is a D. There is a disjoint there. Either undergraduate or a graduate, and the student cannot be both of them at the same time. The same for the employee and the faculty or staff. Again, it is disjoint here. Well, this depends, on the business rules of that university. But sometimes probably it could be an overlap. If the employee can be really a faculty, in the meantime it is really a staff working, in a department, but in the same time really could be a faculty. Well, let's talk about business rules. What's really business rules? Business rules are rules imposed by the customer who order the application. Those rules are irrelevant to the application developer, but they must write a code that enforces them. This means a rule or the business rule. It's like the business requirement. We should have that. So we could write a code to enforce this. Example: every customer must have a name. Is a business rule. Best implemented by declaring a not null constraint and the relevant table column with the customer name. Customer name, it must have a value. So it's not null. This is a business rule. Another example: every invoice must reference a customer record. Every invoice we have, it has to reference a customer. Probably a foreign key and the customer ID column of the invoice table referencing the primary key of the customer table, and a not null constraint and the foreign key. So business rules, specification that preserve the integrity of the logical data model captured during requirements determination and stored in a repository as they are documented. Some advantage of a business rules are: first of all, provide faster response of business changes. Why? Because that rule, it is written and enforced in the database management system. When they want to change the rule, we don't go to change it in any application. They go direct to the database management system in the database definition and change it there. Consistent application of integrity application. Consistent integrity application, this means that it reserves the integrity of the application, because the change is in one place. The way you do it, the way I do it, the way he's done it, it is the same. It is in database management system. Reduce time and effort required to train application programmer. With those business rules, if that business rule, it has to be in 3, 4, 5 programs or whatever. So we put them at one, and we don't need really to train or to make those programmer understand what's that business rules. And so the DBA again put it in the database definition. Faster application development with fewer errors. Of course, when you have the logic in one place in the database management system, database definition, so I think it's gonna be a few errors because one person put it there and it's applied in many different programs. Reduce maintenance effort. Again, it is the same thing. When we want to maintain, we want to change that logic, we go change it in one place in the database definition of the database management system, and it will reduce a lot of maintenance effort here. Well, entity integrity. Entity integrity is an integrity rule which states that every table must have a primary key and that the column or columns chosen to be the primary key should be unique and not null. Which it is, it should be unique and not null. Referential integrity constraint is a rule ensure that one-to-many and many-to-many relationships are enforced with the relational schema. In addition, valid values can also be enforced with constraint. Constraint, which is here, it's a rule governing relationship between entity types, which it is usually dealing with the foreign key. This means, if there is a foreign key, an entity with a foreign key there, it must have the attribute in that other entity with the primary key. Domain, constraint, and a valid value for attributes. That attribute, it has a value of like a gender, male or female. Triggering operation, other business rule that protect the validity of attribute values. Any triggering operation, any piece of logic, the customer try to put it or to ask the DBA to put it in the database management system, because that piece of logic, it's like executed in many different programs. So we put it in a triggering operation and in one place in order to make it to make their integrity. Well, if we talk about domain is the set of all data types and values that an attribute can assume. It has many advantages. First of all, verify that values for an attribute are valid, either gender like either male or female. Ensure that various data manipulation operational are logical, and help conserve effort in describing attribute characteristic. What is a triggering operation? A database trigger is a procedure that is automatically executed in response to a certain event on a database table. A trigger that records the insertion, modification, or deletion of important data will let you know when and why certain changes has been made to the database. As we say here, an assertion or rule that governs the validity of data manipulation operations such as insert, update, and delete. So we put a piece of logic, in the database definition again. Uninsert, so the trigger, it can be like uninsert. When you insert a record there, I think you should do something else somewhere else or in 2-3 places. What is the triggering operation should really contains? What is the really component of it? First of all, the rules. A statement of the business rule to be enforced by the trigger. Event, data manipulation operation that initiate the operation. Entity name of the entity being accessed or modified. Condition that causes the operation or to be triggered, and the action which it should be taken. It's like, a trigger, like uninsert, as we said. Whenever we insert a record in that entity with that value, a logic will be triggered up. It depends on a condition, on a specific condition. So the action will be taken and go update or delete or do something else somewhere else in the database. Okay, the final things we are going to talk about in this lecture and in this chapter, it's the role of package conceptual data models, database patterns. As we know, there are a lot of common things between businesses nowadays. So if you go there to the net and you try to find out, a set of ERD, like an ERD for a hospital system. What's the different, set of ERD in hospital, like the hospital here we have in Just, مستشفى الملك المؤسس, and another hospital in Amman. There are going to be a few of them. This is the main reason. That's why some packages are modeled and put as a generic model, and probably it is in the internet, and for sure it is in the internet. So you could really take it from there and just customize it. And that's what really I suggest and I recommend, for your project. You could really just go and find out the ERD and get the set from there, from the net, and try to change, modify it, or customize it according to the requirement of your project. It's a package data model, provide generic model that can be customized for a particular organization's business rule. Universal data models are templates for one or more core subject area, such as customer, product, accounts, documents, and or a core of business functions such as purchasing, accounting, receiving, etc. So there are a generic. The thing we talk about there are a generic which it covers a lot of the information, the important information for that system. But it probably doesn't go to those little things, the special thing you do it in your business. So you could really start with the generic pattern from there, and you try to modify it and change it and customize it to your database and your system. Well, industry-specific data models. This means it is to the domain, a specific domain for industry. An industry data model is a set of business and technical data models that are pre-designed to meet the needs of a particular industry. It acts as a blueprint. So it looks like a blueprint that provides a common element, or maybe the core element derived from the best practices or government regulation and complex data and analytic needs of an industry-specific organization. This means it is a common. It's a blueprint to cover the common elements needed for that industry. It is designed to be used by organizations within a specific industry. These models are based on the premise that data model patterns for organization are similar with a particular industry. That with the fact that, this organization is doing their business close or the same as the other in the industry. What's the benefit of data patterns and packaged? Well, I think it will save time. And sometimes I think it has really a best practice of others. That's why, really the reason why, because we go to the net and we get the package from there, we get our model from there and start just customize it. So we'll save a lot of time. In the meantime, those people who put it in the net or who else, it is the best practices of other people in the industry. So benefit of data patterns are dramatically reduce implementation time and cost. Provide a starting point for asking a question, whatever, and requirement or collecting requirement from the customer. Higher quality models represent a best practice that modeling techniques and data model component whose value quality often exceed that which can be achieved by internal development teams, given a typical organization pressure. Well, of course, it is high quality because, it is the best practices of others in the same industry. So probably when we look at some of these patterns, probably we could change our way of doing business to go with the line of the people in the same industry and the same domain. Well, to summarize what really we have in this chapter, first of all, we learned that concisely define each of the following key data modeling term: entity type, attribute, multivalued attribute, relation, degree, cardinality, business rule, associative entity, trigger, supertype, subtype. And then draw the entity relationship diagram to represent common business situation. Explain the role of conceptual data model in the overall analysis and design of an information system. Also, we learn how to explain the role of prepackaged database models, patterns in data modeling with the one we just talked about in the last few slides. This distinguish between unary and binary and ternary relationship, define four basic type of business rules and conceptual data model, relate data modeling to process and logic modeling, different views in describing an information system. By this slide, we finished chapter 8, which it is the ERD, the data conceptual modeling. And by finishing this chapter, we are done now with the analysis phase. So the next time we are going to go to the database design and then to the interface design. So we're going to go to the design phase. We finished the analysis phase. What really we did in the analysis phase, we collect the requirement determination. Then we went and to the chapter after that, we did the processing model. The processing model, which it is the context diagram, data flow diagram with all levels from level 0 till the primitive DFD. Then we went to the logic modeling in the same chapter, and we cover the decision table, decision tree, and the pseudocode. And with this chapter, the ERD, we finished all the analysis phase, and hopefully next time we'll go to the design phase, designing the database and interface design. Then after that, the last phase, which it is the implementation phase in the development cycle, not in the life cycle. In implementation, coding, testing, inspection, and installation and data conversion, all these things. And the last chapter, which it is the maintenance. So we go back to the maintenance in order to realize the system development life cycle. So we are done with this chapter. Thank you and see you later.